Perfect. Yeah. Okay. Hello. Right. Yeah. Hi. Hi. Good afternoon and good morning to everyone. So this is the second part of our series R programming data science tool. So lastly, we have covered. I'll just go through what we have covered. In the last video, we have covered topics which are what is data scientist and what are the different roles in very depth, and then different forms of analytics, right? And then the slide which tells us about the better understanding of data science and getting into detailed knowledge of different forms of data science and a day of a data scientist, or you can say a data science process. Then we have covered an analytical tool used for data science and a real world application of data science. Then different industries using data science thing, using different data the tools, correct? And then different companies using R language, and lastly we have covered what is the what is big data and its importance, right? And so now we'll just sum up what we have covered till now in lecture first, which is data science foundation, right? So we'll just sum up and start with the second lecture. Okay, so let's sum up what we have covered till now. Okay, so we have covered data science is a study of mathematics, statistics, information system, which is again a software engineering and a domain knowledge, right? So what you can see is mathematics and statistics. Uh, okay, so mathematics and statistics, these both can come under the one part, okay? And domain knowledge is nothing but a business knowledge, right? And which results in data-driven productive insights, correct? Um, Fine. So the second topic which we have covered is there are four different kinds of data analysis techniques, and these are descriptive analysis, diagnostic analysis, predictive analysis, and prescriptive analysis, right? So then we have gone depth into each of the analysis. Okay, so firstly we have covered descriptive analysis, which is descriptive analysis or can be called as statistics, does exactly what the name implies, right? So it describes the previous data, the history, or we can say summarize the raw data and make it something that is interpretable by human means, right? So this is one of the way, or we can also say that it solves our problem of what has done, right? So what has done in the history by using the raw data, okay? And then we have covered diagnostic analysis, solves the why part, that why things have been done like this way, okay? Then we have covered predictive analysis, which is has its root in the ability to predict what might happen and actionable insights based on data and provide estimates about the likelihood of future come. So simply it does nothing but the modeling and machine learning part to predict what could what could could happen in the future, right? And then we come to prescriptive analysis, which is prescribing the solution, different kinds of solution for a problem, and then choosing one out of them, right? And again, I am reminding you that please do remember the example which I have discussed, doctor example, right? So this is something which I always used to say, a doctor example. So you can differentiate between predictive and prescriptive, correct? Okay, so let's move forward. Then next we have covered the data science process or a day of a data scientist, which includes framing the problem, right? Collecting the data which we need. So if we talk about framing the problem, so again, framing the problem means the CEO or your client will give you a business problem, then you have to frame it into data analytics, which we have discussed very thoroughly in that particular slide, and then collect the data which is needed. So you do not have to collect a random data, right? Or everything whichever is coming, let it become. No. So the key role here in data collection is collect data mostly which can be helpful in solving your particular problem, and then process the data analysis, then explore your data and perform in-depth analysis, right? So firstly perform data analysis, then explore the data, right? And if you still feel that you cannot explore that data perfectly, or there is some problem in that again you can do um, depth analysis, right? And when you're done with depth analysis, then you can definitely communicate your results to your CEO. This part, communicate the results of analysis to your CEO, your client, anyone, right? Okay, so this is done. Now there are different tools available for data analysis. Those are Excel, right? R language, Python, SAS, Tableau, etc. Which is, I mean, all of them have their own pros and own cons, right? On the basis of which we choose mostly, right? So if we talk about R particularly, so R is very good, and we'll definitely discuss this part, right? Specifically R in the very next chapter. So meanwhile, I'll also let you know R is very good in statistical analysis and graphical thing. Very good, because they are having lot and lot of packages in that. Okay, so if we talk about Python, then Python is something again open source language, and very good in you know uh, advanced form of machine learning, or you can say, if you have heard of this, uh, deep learning, right? So this part is very good in deep learning, right? So SAS base is open source, and but again the advanced version of it's commercial, right? And then we have Tableau. Fine. Okay, so this we have covered, right? And next we have data science example, which include Gmail spamming, which we have covered. Then it's personalized update in social sites like Facebook, right? Twitter, Netflix, then recommendation system in YouTube, right? And then we have industries catching data science. So there are a lot of different industries, as we have discussed, catching this data science part. Okay, and namely healthcare, retail banking, insurance, e-commerce, then search engines, web analytics, and a lot more. And so, as we have already discussed, these are some who have catched the things, and again they are trying to applying data analytics in more critical part of their job. And at the same time, there are a lot of more industries who are trying to catching up with data science, because as we have told you in the very first slides, that data science is something which is add up to your skill. It is nothing a different thing, but it will add to your skill. Maybe you are from product management or manager position, or a techie guy like software development, software testing side, right? So data science is a skill by which you can analyze the thing and can get insight out of it, right? So very helpful thing. Okay, so let's come to the next point, which is list of companies using R languages. These are very known companies: Google, Microsoft, Facebook, we have eBay, Ford, and many more, as we have discussed in the slides, right? And last but not the least, big data, which is a very big buzzword, right? This helps us to uncover the hidden patterns, unknown correlations, right? Market trends, customer references, okay, and other useful information that can help organization make more informed decision, right? So this is again future, right? So this is something belongs to future, right? Very, very helpful, correct? Okay, so till here, if you have any kind of doubt or anything to clarify, please do let me know. I'm more than happy to help you, and then we'll jump to the next lecture, which is intro to R language. So I'll just wait for a few seconds, that if you have any kind of doubt, then please do let me know in the chat window.
No doubts. Please continue.
Okay, okay, perfect. Thank you so much for confirmation. And okay, so let's move to our next thing, that is R language intro. So again, this is what we are doing here, the R language. So first we'll have a history. What is R language, right? So what all we cover here is what is S plus S and R language. So these all three things are related to each other. We'll cover that. And then why to learn R? I mean, why R? Why not Python? And why not SAS? Or why not something else, right? And then we'll discuss cons and pros of R, right? And then very next is before learning R and RStudio. So before learning R is a slide, you know, which will give you a basic knowledge of few things which are required very, very often while you are programming in R language, right? And RStudio, and we'll get into depth what is RStudio, right? So this is something IDE, integrated development environment. I feel you guys, I think you know, or if you do not know, I'll explain it in the very slide. Okay, and then we have data structures in R, which includes very, very different forms. So we'll discuss each of them with the what is it, then examples, and what all basic operations we can perform over it, right? So we'll start with vector. Okay, then we have metrics. The same thing, we'll have a very good discussion over that, with what is metrics, examples and operations. Then we have data frame, same thing, example, operations. Then we have list, then we have factors, and we have packages, data sets. Then we have some special values, right? So special values are some, you know, again, as the name suggests, some special things which are not used more often, but definitely it's good to know, right? And last, we have functions. So function, again, we have two different kinds of function: user defined and predefined. Okay, uh, fine. So like before getting into, you know, starting with this very first slide, I would like to know, like, anyone have any kind of experience in any programming language? So this will make me a bit, you know that you how familiar you are with any programming language, not in data analytics particularly like R, Python, but anything like C++ or maybe Java. Please confirm me in the chat window. Okay. Okay. Perfect. Like, so some people have experience in not R, but other languages, and others are very newbies. Great, great. So we will cover here from very, very scratch, right? So the name of this lecture is again R language. It's a very, very introduction to this chapter, and you do not have to worry at all if you even do not know of any language, right? So we'll cover each and everything. So and we keep on moving, and you'll come to know, like, you at the end of this lecture you come to know very, very good things which are used in day-to-day life of data analysts, right? Okay, so let's get started. Okay, so let's start with the very first. What is S plus and R? Okay, so S is nothing but it's an interactive environment. It's again a language for data analyst, right? Which was developed by Bell, sorry, which is developed at Bell Laboratories in 1976, correct? And after that, so basically this is something which is for pure data analysis, And I would say at that time when it was developed in 1976, there was no Python or something, right? So R was the king of market that time. But then gradually time passes, and then in 1988 the language turned into S2, right? Upgraded, and that was done by R.A. Becker, J.M. Chambers, A. Wilkes, right? And in 1992, it becomes name becomes S3. The same people, J.M. Chambers, T.J. Hasty, right? And in 1998, the version comes S4, and that was by J.M. Chambers, correct? So till 1998, it was the a version of S, right? It was again S, but the different versions of S, right? So um, but then it came with a license by AT&T Lucent of to Insightful Corporation, which is then settled WA, and the product name become not S5 but S plus, right? S plus. This is how we denote, right? S plus. And initially, so S plus is something that is R, right? So S plus is something which is R. Then R initially written by Ross Ilaka, right? The pronunciation is like this. And Robert Gentleman at Department of Statistics of of Auckland, right, in New Zealand during 1990s. So New Zealand, a very beautiful place, right? And again, a very beautiful invention. R is very helpful in statistical and graphical. We'll study this in further slides, right? Okay. And then now, as we know, like when is R developed, and then how about S plus, then we have got how is R done, right? And now we'll come to what is R basically, right? So every programming language has some sort of things, like some are functional programming language, right? I'll write it down. Some are functional, based on functions. Functions programming language means based on this thing, functional, right? Some are object oriented, OO, which is called OOPS. Object, this is called object oriented programming, right? Okay, but here if we talk about R, as you can see, it's a functional programming language. It's not a OOPS. So if we talk about OOPS, so Java is one of them, which is very well known, very good language, right? And very secure, right? And you can use it in any platform, very helpful thing. But it's again OOPS. It is based on OOPS. I don't know you have heard this name. The ones who's having hands-on or have knowledge of programming side, they'll definitely know what is OOPS, right? And the ones who are very new, so you will come to know today itself that yeah, there are two kinds of mostly OOPS and functional. So Java is something called OOPS and R is functional language, and this is written primary in C. So this language is written in C. You must note this point, C, right? By Fortin, developed at core team, right? Okay, and then the GNU project, which is a GNU is creation of free operating system. That is what is GNU, right? Developed by John Chambers, again the same person. This is at Bell's Lab, right? So, and the very next one is it's free software, which is a very huge advantage, right? Like if we talk about SAS, SAS is something which is free just for normal things or SAS base. And then if we move to higher level, it is commercial thing. SAS is not freeware. Up to some extent it is free, but at higher level, it's not free. It's not free, right? And if we talk about R, it's a free language, right? Free software environment for data manipulation, statistical computing, and graphics display. So as we have discussed, R is good for statistical computing, graphics, right, and data manipulation. Why? Because they're having a lot of packages and it's a free language. So lot of people have, contributed in making different packages, and hence others can use them. That's why it's becoming very popular day by day. The graph is, like going this way, high and high. And because of this, there's large community which is using our language, and there are a lot of people you can find for help. And also, as I have promised, that I'll share with you, few helpful resources by which, if you are new to this language, then also it's very, very helpful. Or if you are expert in this, then maybe you know about those resources, or you will come to know by the end of this lecture or video, right? Okay. And so as we have discussed, it's free. And uh, right, so it's free, and it's very, very helpful in data manipulation. Manipulation means wrangling of data, right? So you are doing, you are sorting out data, you are exploring data. That is called manipulation, right? You are manipulating your data. Okay. And then statistical computing and graphic display. Correct? Fine. So let's move to the next slide. And in case if you have any doubt, please you let me know in the comments chat window, right? Meanwhile, I'll just keep going. Okay, so why R? So here is something people ask me many a times, uh, that should I choose R or should I choose Python? See, they say R or Python, right? So because newbies are like, I mean, which language should I start with? Is it R or Python? So see, what I suggest them is both languages, as I have discussed, like both languages have different cons and different pros, right? So it totally depends, like what work you are doing, correct? And we'll discuss in the coming slides that what exactly are used, and here even we can come to know very, very good details of R, and in what particular things the R is good, and hence you can correlate with your business that is this thing required in my business. If it is required, then definitely R is very, very good. And again, R is very good in data manipulation, statistical technique, and graphics. So these are some main features of data science or data analytics things. Okay, so let's start with the very first. That is, it relates to other language. So it is very easy to relate with other languages with R, right? And it, as we have discussed, it has a vast community. So so it has a vast community. So it is very easy to get help or anything if you have any query, right? And it supports extensions. So there are a lot of different extensions for different kind of things, right? So you can get extensions support for that extension also, which is a very plus point of that. And then we have extremely comprehensive, very comprehensive. I mean, you do not have to worry about, it's a very comprehensive language. And then flexible and fun, right? So although if we compare between Python and R especially, then Python is we used to say people are used to say like Python is something which is easy to learn. But what I feel is R is very, very easy and flexible, right? Because it totally depends what you think. But at the same time, yeah, there's no doubt that Python is something which is very human readable. Coding is done in that language. But at the same time, R is not that much tough, right? So there are a lot of languages which are very, very tough in terms of doing coding. But if we talk about particularly R, it's not that much tough. So we can say it's flexible and fun, right? And then we say outstanding graphs. So as we have discussed earlier, it has lots of packages, especially ggplots, right? Yeah, here I'm writing, especially ggplots, which is helpful in graphics, right? And right, so these kind of things, very, very helpful. Then advanced statistical language, right? So it is one of the core feature, advanced statistical language, outstanding graphics, right? And data manipulation. Okay. And then we have cross-platform compatibility, right? So what is cross-platform? So cross-platform means it can be used on Windows, right? You can use R in any platform, in cross-platform. It can be used on Windows, it can be used on Mac, correct? It can be used on Linux, Ubuntu, right? So you can use of any of them. This is something again which is very, very helpful in R and very good feature. And again, last but not the least, it's an open source language, which is a very beneficial thing, because if you have to pay for the license of for any language, then that requires again a huge amount of money in investing just to get the license to use. And R is one of them. But again, there are a lot of downsides and upsides of open source, right? So I mean, nothing is good, nothing is bad. So everything has downsides and upside. So let's talk about particularly R. So as it's an open source, so we do not need any license, and it's very, very easy to use it without any investing of money. But let's take it a view on the languages which are not open source. Let's say SAS, right? So as we have told, SAS is not an open source. So what are the benefits of this? So SAS is license. You have to take license at particular time to use this language. But what thing makes it why then, if R is an open source and Python is there and lot more other, so why do people choose SAS? So this is a very, very good question which sometimes interviewers ask. So the thing is that it is, if it is license based, then it is secure at some extent, right? It is secure. Secure means your data is secured, right? So there are companies mostly in banking side, okay, retail banking, then insurance is there, okay, then we have insurance, then other different fields who use this particularly tool, correct? And why? Because their data is very, very sensitive. They cannot afford to leak anything from their data or any theft thing, anything like that. So they use, say, SAS, better protection and all those things. But again, R is very, very useful and used in very different industries, as we have discussed earlier, and very different companies like Facebook, Google, and all those things, right? And even sometimes banking, very less, but again, they do use R and Python. So it totally depends what problem you are solving, correct? And then if you want to install R, so you have to maybe in like as I discussed, it's a cross-platform compatible. Then R, to install R on your Mac or PC, you need to go to this link, just click it on, right? Or you can type it on, then you can go to a link, and there you can download for R for Mac or for PC with a different download options, correct? Okay, fine. So let's move to next slide, and in case if you have any doubt, please do let me know. Right. Okay, so now those are again the upsides. Now let's get into the downsides and some more upsides or pros of R, right? Cons and pros of R. So let's start with cons because then we'll come to know after cons, then we'll check out some more pros, which is very, very good and very, very helpful to writing code and all those data analysis part in R. Okay, so let's start this. So R, like everything in life, has its own issues, correct? This is very true. I feel you are agree with me and appreciate this point. So in the same way, R has, first is, it has a steep learning curve that is difficult to master. But here is the solution. What is that? This is, practice can make a man perfect, right? So what we need is practice, practice, and practice. And definitely in any language or anything to master, so there is no shortcut, and especially in data science, there is no shortcut. You have to learn, keep practicing, and the more you practice, the more you give hands-on to the language, the more you will get, right? And that becomes very, very easy for you to get things done, correct? This is the first point. And the second point is there is no default parallel executions and has limitations while working with large amount of data sets. So by parallel execution means you cannot run two things at the same time or more things, more than two, right? Two or more at the same time. Okay, and has a limitation while working with large amount of data sets. So yeah, this is somewhere it's a lack at sometimes that it cannot work with a large amount of data set, correct? Okay, so now to come to pros. So this is very helpful. So R has more than 45,000 packages. It's a huge number, 45,000 packages available for multiple repos. Repos mean repositories, right? Specializing in topics like data analysis, which we are discussing here. Then we have bioinformatics, special analysis, etc. Right? So these are again the different fields where we can use R, right, in different forms. So bioinformatics for bioinformation thing, right? And this is what which is very good what I feel, and till now it's 4,500 more, but in the coming days it will be again very more, because it's an open source and everyone is trying to helping to make it much bigger and bigger, right? So if you are getting, if you're using it, if you're taking benefit from something, then definitely I feel you should contribute also. That is a that's what called humanity and human nature, and believe me, our people, our freaks are very good in this, right? So they have devoted very good packages to do very different things, right? Okay, this is one thing. Then second thing is free and open source with online help discussion. So we have discussed this. It's a free open source. So as it's free, so online help and discussion is very helpful, and there are a lot of people to help you out. Third is our visualization capabilities and interface with other languages. So again, visualization capabilities, which is I've explained you graphics. I mean, excellent in this language, and interface with other languages is again very easy to do, correct? Okay. Okay, so now let's move to before R learning and R studio. Okay, so what is before R learning? Before R learning is nothing, something different, but it's the thing which you should know before starting R. That's what I feel personally, right? So before getting into something or before starting anything, you should do a bit of homework, so that makes your life very easy, correct? So that's what I feel. These are some things which you should know before getting into R, correct? So let's start. Assignment operators. So assignment operators mean if you want to assign 5 to, let's say, R, so you can, this is R, right? So you can assign it by using this operator. Normally in many different languages this operator is used, and here also you can use this, but mostly people use this. So although you will not use this, I mean, what I will say is you should use this one. Okay, you should use this one only, but if you want to start with this, then that is again perfect, but you should have a knowledge of this. So at least if someone is writing or you're searching for some result, so you should have a knowledge, yeah, this is a assignment operator, but nothing complicated thing, right? So how you do is like R, arrow, this, and 5. Easy, yeah. So what this doing is you're assigning R to a value 5, okay? And not only you can do by this, you can change the arrow sign. You can do 5 assigning to R, correct? You can do this also. So again, this is something which is not normally done. This is a convention which people mostly use, right? This way. But again, you can use this also. No worries, R will understand you very good enough. I will understand you in very easily, correct? And you can use this as I said, okay? Okay, so next point is R line or code ends with a new line or can be separated by semicolon, okay? So let's say you have written this command only, R code, right? You're assigning 5 value to this. Now, this code is finished, right? This line is finished. So if you want to write next code, so you can either use next line. So this is one line, right? End this, and next line starts from here. Let's say P, we're assigning P to new value 1. Okay, so you can start by this, or okay, or you can put a semicolon here, okay, and you can write here. So both the ways R will understand you that you are assigning value to this, right? And if you do not use this, and even you do not use new line, and you write this after this, one after the other, then definitely R will get confused and it will not able to understand you at what you have written, correct? Okay, so comments can be written after hash. Okay, so normally the people who do not have any experience into programming language, right? So I want to let him know that we normally use comments to, understand the code better, even by the software developer who has written the code by himself or by the other people, because in a day you write a lot of codes, and if you come back to that code, in after maybe say 2-3 months, and you will not remember what you have written, so you have to go through each of that, and that will be very hectic and time consuming, right? So you can use code comments to understand that code easily, and in R we can use comments, we can write comments after putting hash. So after hash, whatever you write, that will be counted as comments, right? That will be counted as comments. I'll show you. Okay, I'll show you, and we'll have a hands-on over R also. Okay, so let's say we assign R value to 5. Okay, we have assigned this, so we have done this. Okay, and then you use this one, right? You first select this code and then press this. Just a moment. Okay, so we have to run. You have to click on run, right? So if you noticed here, what has happened is, okay, so let me clear. Oh, so sorry, I have not discussed the RStudio with you. Okay, cool. So let's first discuss RStudio, and then I'll let you know. So that was RStudio, by the way. This was RStudio, right? And what is that? I'll tell you in the same slide. This is, here it is, right? So let's discuss this, and then we'll get hands-on over the same, right? Okay, so so hopefully you are clear with this. First you will use hash, correct? And then whatever you write, that will become comment, correct? Okay, now this is get W, and this bracket means, what does means is getting working directory. So working directory is something where you are working, right? Directory, right? That what sections particularly are working. So working directory means at what particular directory you're working. If you want to know that what particular directory you're working, you can use this command to know. And then if you want to know, if you want to set your directory, so whenever you open your RStudio, and that I will discuss what is RStudio, you need to first set your working directory, right? So before setting, you cannot use it. So setting working directory means you are setting a folder or some place. So definitely in Windows you have folders. You'll set a folder, and it will work like this, like set set w d and bracket start, this like this way, right? And here you will write the address, which folder. Let's say it's a D folder and it is present in desktop, right? So you'll write that, and I'll show you. I'll show you. Okay, so after starting RStudio, you have to set your directory first, only then you can start coding, right? Okay, so if you want to know the list of directories in your current directory, I mean what all folders, files are present in your current directory, then you can do that by this command. And if you want to know the list of only files in your current directory, then you can use this command. Fine. Okay, so let's start with RStudio. So RStudio is nothing, it's an IDE. I feel I have discussed what is IDE, or let's discuss one more time. IDE is nothing but it's an integrated development environment, right? Integrated, it's an integrated development environment, right? Okay, so what does this means? What is integrated development environment? So this is something, this is made, and this is more almost in every language you can find IDE, right? So IDE is something to help you to write better code, right? And it saves your time, and I would say a lot of time, right? So it will suggest you different codes, right? So it's an integrated environment where you can use your coding to save your time and lot of suggestion and making your coding skills again easy, right? So this is something, this is like which I have told you. Okay, RStudio. So RStudio has 4 sections: 1, 2, 3, and 4. And again, you can also interchange this, right? If you want this to come here, you can do that in the settings, right? But normally things goes like this, right? So first is code editor. What is code editor? Where you can write your code. Here you can write your code, right? And second is R console. Here you can see your output. That is R console. Third, workspace and history. So whatever you write code, that history, or if you know, write any variable or make any file, then that will stored in workspace. So this is workspace as well as history. Everything gets stored and you can see that from here. Okay, and if you use, so R is, as we know, it's a very good in graphical thing. So if you use any graph, right, or anything, right, plotting or something, you can see that particular thing here over here, right? So this is the thing. And if you want to know deep into this, then I'll start working over when you start working over RStudio, then you'll come to know that it's very easy, and you'll be used to it. Just in 2-3 days you'll see that this is nothing new and nothing tough at all, right? Okay, and if anyone has any doubt, then please let me know in the chat window, or you can just say it, right? Okay, perfect. So I feel everyone is fine. And okay, so everyone is fine. Perfect. That's very good. So that means you are learning the things in very good pace, and that is truly good for you as well as for me. Okay, so this is R. So let me have a look what how the RStudio looks, right? So this is what we have seen, first section. Here we write our code. This is the R console where the outputs looks, right? And then just I'll pull it if it works. Yeah. So this is history and workspace where the variable will store this one. Sorry. So I have interchanged it, right? I have made this part. Okay, let me show this part as a history and environment, and this part as a, you can see graphs over here. Correct? Easy? Okay. Okay. So while we'll code, you can see what are the other things. Correct? Okay, fine. Okay, so now before getting into data structure of R. I would like to know if anyone have any doubt in data science part or anything, because we are right now we are starting with R, data structures, and hopefully everyone has confirmed me that there's no doubt, right? So now we can start with data structures in R. Okay, right. So let's get started, and it's very interesting, believe me, very helpful and very interesting. You'll love it. Fine. Okay, so let's get started. So what is vector? So vector is nothing. It's a one row and n column. What does that means? See, I'll give you a view. This is a matrix. You must have known. This is the first element, second element, third element, fourth element, fifth, sixth, seventh, eighth, and ninth. Okay, so this is 3 into 3 matrix. We call it this is 3 into 3. And what that means, 3 into 3 means 3 rows, R means rows, C means columns. First row, second row, third row, correct? Sorry, first column, second column, and hits third column, right? And then first row, second row, and third row. Easy, right? So now what is vector here? So vector is something which is having one row only and n columns, right? So let's derive from this matrix. What is vector? See, one row, that means we have one row, this one. And definitely we have 3 columns. So it can be n number of columns, okay? So that means vector look like something this, having different values, 5, 6, 10, 7, something like this, right? So this is one row only and n number of columns, 1, 2, 3, 4, and so on. You can keep on increasing it, right? So this is a vector. Okay, so we have cleared with this. Now it has a one data type only. So data type means what type of data you are adding. So basically how many types of data we have. Here you can see numeric. Okay, numeric is like 1, 2, 3, numbers, right? 4.5, 4.5. These all are numeric, right? Then we have characters. Characters is like A, B, or capital C, capital D. So write alphabets, A, small a to small z, capital A to capital Z, right? All these are counted as characters, right? Now date. So date is very well known by everyone. So date, month, and year, right? So this is again date, month, and year. This is called whole date, right? So yeah, so this is date, data type. What is it? Data type. Or logical. Logical is, what is logical now? It's true or false, right? It's a logical thing, na? So these are called logical operators or logical data types. So or and are operators, and true and false are data types, correct? So these are logical, and we'll discuss it when we'll get into more depth, right? Okay, so we have cleared with this that one row, n columns, and one data type only one data type. Okay, so what does that mean? That means a vector can handle only one data type. Either it can be numeric, that means a vector should have either all the elements of a vector should be numeric, either character or date or logical. It cannot be like some are numeric and others are character, right? So mixture cannot be done here. Vectors are something which cannot have mixtures. it should have only one type of characters. I feel this is clear. Then what are the uses? So track changes in single variable over time. What does that mean? Track changes. So let's say this is a speed. Okay. So this is something called speed. Okay. This is a variable in graph. It is increasing here. And this is a random 0, 1, 2, 3, and so on, right? Okay, so what does this mean? Track changes in a single variable over time. Okay, so if we draw like this something, okay, so speed is changing over time. That means at these are different points. At different points, which is increasing it this way, speed is changing, right? So it has only a speed thing which is changing over a time. So this kind of thing comes under vector. And examples are stock prices. So stock prices again, and we'll see in coming slides also. Stock prices, like it keep on changes, sometime down, 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 then up, then down, down, down. So here comes the stock prices. Here stock prices with time, right? Okay. And financial performance, sports score, so different thing. But the basic funda is it should have one row and n number of columns with only one data type. Easy? Fine. Any doubts, please do let me know. Okay, so let's check an example. So we have discussed previously. So here it's showing that this is a vector, right? Because if you know, we have discussed that this is assignment operator. So this value which is coming under this quotes, right? And this is assigning by this to DURL. That means DURL is a vector, correct? So it can be anything, remember, but it should be only one data type. So earlier we have seen a numeric, and here it's a character data type. Perfect. Okay, so when you do this command, you can see what you have written, and here it is output, right? So you have written this, and which is showing here, right? And if you write mode, the name of vector, then it will show what type, what is the data type of vector. So it's showing character, right? We have discussed. And dim, then vector name. Dim means dimensions, and we will discuss these functions in the coming slides. But for now, we need to concentrate on what is vector, right? So dimensions. So character thing do not have dimensions, right? So null, no dimension, correct? And this is one of the example where you are having longitude of point A, longitude of point B, right? Different longitudes, a longitude of latitude of point A, longitude of point A, latitude of point B, longitude of point B, right? Different things. So this is a vector where you have this latitude of A, then longitude of A, then latitude of B, then longitude of B, and khatam, and finish, right? So this is the value of this latitude of A, then longitude of B, and so on. So it is having only one data type, right? And one row with n number of columns. These are n number of columns, right? Okay, and this is again which we have discussed, stock prices, right? So stock prices increase and decrease with the time. In 2008, the stock price was $4.68. In 2009, it was different, and then different, then different, then different, right? And this is the weather forecast. So in different days like Sunday, Saturday, Friday, and all are in morning in AM, right? So different weeks, we have different speed, 65 mph, 90 mph, different, right? So single data type, and in a one row, that is called vector. Hope that this is more clear with you. Okay, now the basic operations, right? So let's see this, what are the basic operations. And in the next chapter, which is again not included in demo classes, we will see how we can gets hands-on over this, right? Okay, so first we need to see what is C here. So C means concatenation. Concatenate, or you can say, okay, concatenate. And what that means, sometimes we call it combine to, you know, understand, to make it simple, right? But this is concatenate. Okay, so you're combining, this is what called concatenate. So you're combining one from 1 to 3, right? So this is one code, and you have put a semicolon, and you have written V, and when you press run, then it will give whatever it has stored in it, correct? Okay, then we have mode V again. So mode, variable name, it will tell what type data, what type of data, what data type is stored in V, that is numeric. Okay, and now we are assigning different values to the same variable V with concatenation. This is a character type now, one, because it is into quotes, right? So whatever is into quotes may be a numeric value, that will be counted as character only, right? That will be counted as character, right? Because that is in quotes, right? Quotes. Okay, so okay, so it includes 1, 2, 3, right? This value is assigned to variable V, and then we write V and press run button, then it will show the elements of variable V, which is a vector, and it shows 1, 2, 3. Okay, and when we put it into mode, it will show what type of data type, that is character again. Okay, and then we are assigning different values to V, that is logical. Here we have done numeric, this is character, and here we are doing logical. As we have discussed, logical is true, false, so we are concatenating it and showing it in vector V, and then when we print V with run, right? So it will show true, false, true, which is the elements of variable vector V. And when we put in mode, it will show data type, that is logical, right? Okay, now we are putting PI. So what is PI? PI is, I think we know pi, right? Pi, you have seen like this, which is a value of 3.1427 something, right? This is a constant variable. This is a constant, and it comes under special characters, right? So we'll discuss in further slides. But meanwhile here, what we need to understand is it is storing the value which is in pi, right? And the next element is 2 into pi, and the next is 3 into pi, right? And when we write V and press run button, then it will display the numeric value, because pi stores value numeric 3.14159, right? So it will print numeric value, correct? 2 into pi means 2 into 3.141, 3 into pi means 3 into the value, right? So it will give you the value, and when you put it into mode, it will give you the data type, which is numeric. Here it is, right? Okay, so now numeric value coerced into character mode, right? What does it means? What does it means? Yeah, this means that, see, as we have said, that vector can contain only one type of data type. But if you see here, it's a numeric value, right? And this is a character value. So how can this be a vector, right? But there is a property which says that if you store any element with a character type, then that element will also become character, and hence the vector will become character, right? So here we are using uh, character type, these 1, 2, 3. So this will again become a character data type, right? And when we print this vector V, then you come to know that this is character or not. See, when you print written V and press run button, then you'll see one comes under this quotes, which means I have told you, which means it's a character type, right? So now because of these character types, this is numeric value converted into characters and hence they become character. These all are become character, and when you write mod V, then it will show character type. Fine. Okay, so few operations which we can perform in addition, subtraction, multiplication, and logical comparison, which is so this is assigning a value to vector, and this is again assigning a value. And then when we do mod V, it will say V1 is numeric, mod V2 it is again say numeric. And when you do addition, this means here V1 has 1, 2, 2, 3, and V2 has 10, 10, and 10, right? So 10 plus 10, 10, let me write it down. So 10 plus 1 is 11, here it is. 10 plus 2 is 12, 10 plus 3 is 13, correct? So it will show addition. And now multiplication, the same way, nothing differs, right? So you have V1, V2, which you have defined above. And when you do multiplication, V1 into V2, so it will do 10 into 1, which is 10, 10 into 2, which is 2. So it will multiply the same index value. The V1 having index 1, 2, 3, right? And V2 is having 10, 10, and 10. So whenever you do operations like addition, multiplication, so it will do operation over this, having the same index value. It's not printing, okay. Same index value, okay. So 10 into 1, 10, 10 into 2 is 20, 10 into 3 is 30. And same with division, the results are here. And if we divide, this is we have done V1 by V2 and this is by V2 by V1, right? Simple division. Same with subtraction. When you do V1 minus V2, it will comes in negative. When you do V2 minus V1, it will come in positive. Easy. Logical operator. What does this mean? This means that you're comparing, as we have told you, double equal to means comparison, single equal to double equal to means comparison, single equal to, or this arrow sign means assignment. So these are assignment operators. This is comparison. And what is comparison? So they are comparison like the value of V1 at particular index is equal to V2. No, first value of V1 is 1 and V2 is 10, right? So it's false. It's not equal, so it's false. Okay, then second value of V1 is 2 and V2 is again 10, so it's not equal, then it's false. Okay, and then again third value of V1 is 3 and V2 is again 10, so it's again not equal, it's false. So all three statements are false. Okay, this is the comparison operator. And what is this? Exclamation equal to. So here exclamation means not, right? Not. And equal to means again equal to with exclamation is a comparison of, but if it's single, then it's an assignment, right? So what this means is not equal to. It means not equal to. Okay, so V1 is not equal to V2, correct? V1 has 1, 2, 3, V3 has 10, 10, 10, right? So they are not equal to at any index value. So everything is true. Okay, and this is very, very simple. This is saying, is V1 greater than V2? No, V1 is 1, 2, 3 and it's 10, 10, 10. So correct, it's everything is false. Is V2 greater than V1? Definitely. V2 is 10, 10, 10 and V1 is 1, 2, 3. So it's every point is true. Fine. So these are the basic operation which, you know, do not need much attention, but at the same time, if you're doing at starting level scratch, so definitely we need it. Okay, so now here comes indexing, selecting and sub-indexing in the vector only, right? So we will see what is that. So indexing is, first I need to tell what is indexing. So this, you know, that it is concatenating 1, 2, 3, 10, 10, 10. This is value which is concatenating into this. Now what is indexing? Indexing means this one has index value of 0, 2 has 1, 3 has index value of 2, and 10 has index value of 3. Maybe I can write 3, and 10 has 4, and this is 5. Okay, so these are different index value, right? So here, oh sorry, it start with 1. Okay, so sorry. Okay, so it start with 1, then 2, then 3, then 4, then 5, then 1, 2, 3, 4, 5, 6, right? There are 6 values, so they're having 1, 2, 3, 4 respectively, 1, 2, 3, 4, 5, 6 indexing value. Okay, then by default column names are used as indexes, right? So column names, because here the row, if you see here, row is 1, but there are different columns, 1, 2, 3, 4, 5, 6, right? 6 columns. So that means index belongs to columns. So this is what it is written, that by default the column name numbers are used as index. Correct? So if you write this statement, which is v3 square bracket 1 square bracket close, this means you are fetching the first column, right? First column element, which is 1. So but now second is, but columns can be given meaningful names, right? So you can give names to your columns if you want. How? Using names function, correct? Using names function. So what this doing is name and then vector name is they are fetching. If the v3 vector has been assigned any name, then please fetch it. But we do not have mentioned any name, so it is showing null. What are the current column names? This means, and it is null because we don't have assigned. Now we will assign it. Rename column names. So this, and we will do assignment operator, then again concatenation. So we are assigning this column names now because we have mentioned it names. If we will see v3 and then concatenation and all those things, then it will assign as a value. But if we are saying names and v3, this means that their column names are assigned. So now one value has column name first and second, third, fourth, fifth, and sixth, right? And now when you do names equal to n3, that means you want to fetch what are the names. So it is displaying one, first, second, third, fourth, fifth, sixth. Okay, and when you write v3, now it will not only display you the values of your vector, but it will also display the name of your vector, column name with the value. So first is assigned column name and element 1, second column name element 2, then third, fourth, fifth, sixth, as it is, right? Now we can use names as an index. We can use names as an index also, right? So earlier we were using v3 and bracket 1. This means we need the first column element. But now we have assigned name to the column. So if we want to fetch the sixth column here, so we do not have assigned any name. So we'll say v3, the name of vector, and 6. So it will fetch the sixth element. Okay, but here as we have assigned, so we can write in this quotes, in quotes, sixth, right? If we write only 6, then it will not give you anything because it's a name, right? It's a character, and remember character is always written in quotes. Okay, so this 6, so he want to fetch, and he'll fetch column name is 6th, value is 10. Okay, and you can also do this thing this way I have told here, right? Okay, now if you want to see the value of column first and sixth, so if you want to see more number of columns values, you can use concatenation like this way, included in this brackets, right? Brackets are needed if you are using index, right? So these are column names and you're fetching it, so it will show first column name has 1, sixth has 10, correct? Okay, now -1 sign, if you use -1 like v3 and index value is -1. So what does this means? Minus means subtracting, right? So the same way it is subtracting the column, first column, it is subtracting the first column itself from v3 vector, v3, and if you say v3 -5, so this means subtract the fifth column, right? So this value will get removed from here. So as we have said, here minus 1. So see, the first column have been subtracted. There is no first column, started from second, third value, fourth value, fifth value, sixth value. Correct? Yeah. Okay. Now select values equal to 10. So this is so V3 we have vector, and inside our square brackets we are saying V3 equal to 10. So now see, it is not assigning any value. It's a comparison operator, right? So comparison operator means it is comparing, like, please mention those values whose value is 10, which is equal to 10. So remember, fourth, fifth and sixth value have 10, so they have displayed that. Okay, so this is again not equal to, now display all those value which is not equal to 10. So 1, 2, 3 is something which is not equal to 10. Okay, and if we say median, then it will find the median of V3 vector, and hopefully you guys must know what is median, right? So in case if you don't know, I'll explain it to you. Median is something, let's say this is a numeric value we have. Median is the middle value. This is 1, 2, 3, 4, 5, 6. If we have 6 values, then the middle value is uh, um, 3 and 4. So out of 3 and 4, we'll select the middle value. Correct? So that is called the median. So in this case, we are getting 6.5, right? Here you can see 6.5 is coming under 3 and 10, coming in between 3 and 10, right? So that is 6.5. Okay, right. And selecting the values here, so V3 is less than, so he wants to know all the elements whose value is less than the median value, right? So median value is 6.5, all the values which are less than 6.5. So that is 1, 2, 3, and we have 10, 10, 10. So 10 is greater than this 6.5. So 1, 2, 3 is displayed here, right? Now we want the values of V3 whose values are more than median. So median is 6.5 and more than this is 10, 10, 10 here. So displayed it 10, 10, 10, correct? And now we want V3 values whose V3 values where it is less than the median, right? So see, again, it becomes a logical statement more. How it is comparing, like, is V3 less than the median of V3? Median of V3 is 6.5, correct? So in first case, value is 1. So yeah, definitely it is less than 6.5. That's true. Then it's 2, second value. It is again less than 6.5. True. Same case 3. But in fourth case, we have value 10. So is 10 less than 6.5? No. No and no, right? This way. Okay. Now, test if value is an even number. So how will we test a value? We'll check the reminder, and how we can check 2% sign finds the reminder, right? Like this sign shows the division, the same way 2% shows the reminder. And what does that mean? V3 percentage 2 means we are doing division of each element with 2, right? And then the reminder of that at particular index at each element, we are comparing, because we are using double equal to with 0. If it is equal to 0, that means it's an even, right? This is a simple funda which we use, right? So let's check with one by one. V3 first element is 1. So is 1 reminder is 0? No, it can't be. If we divide by 2, no, it can't be. And if we divide 2 with 2, would be reminder 0? Correct, it would be 0, so it's true. And 3 divided by 2 would be the reminder 0? No. How about 10? Yeah, true. 10 will be divided by 2, it will become 0 as a reminder. And the same, 10, 10, 10. Okay. Now, here what we are doing is, again, we are finding the reminder and comparing it with 1, right? That in that case, we were comparing with 0. Here we are comparing with 1, right? Okay. So by going through each of the element, V3 first element is 1. 1 by 2 is equal to 1. Yeah, that's true. It will be equal to 1. And in all further cases, it will be false, right? So it will not be equal to 1. If you're not clear, you can do calculation manually, and in case if you have any doubt, you can let me know right now. Correct? Okay, let's move forward. Okay, so here comes the matrix. So matrix funda I have already told you what is it. See, these are the different matrix elements of a matrix. So it's a 3 into 3 matrix, you can see. And how is it? I'll again explain you. So see, this is first column, second column, third column. This is first row, second row, and this third row, right? So 3 into 3 column. And what is the property of matrix? So it can have n number of rows and n number of columns, right? But what is the similarity of matrix with vector? That it can have again only one data type, right? So in real-time situations, the things do not have one type of data type. It will have a lot of different types of data type, and that will be included in further data structures. But again, this is also important, so we are doing this. Okay, so again, it can have n number of rows, n number of columns, and data type can only be one type of. It can be either any combination of numeric, character, date, or logical. And basically a collection of vectors is called matrix. Please excuse me. Okay, thank you. Okay, so basically a collection of vectors is called matrix. Why? Because they both have the same thing. They both can carry only one type of data type, right? So if we can see this can be concluded as one vector, second vector, third vector, right? V1, V2, or you can give any name you want, right? So these are just an example. So this is a combination of different vectors which can make a matrix, correct? So this is the similarity between them. Okay, so let's move forward. Okay, we have covered this. So let's take an example, which is very good, right? So we have seen this part, correct? Okay. So now, see, two properties, n number of rows, and definitely it has 1, 2, 3, 4, and more can be, right? And this is 1, 2, season 6. So 6 different types of rows, right? But the point to be noted is it has only numeric value everywhere, right? One type of data type. So this can be come under matrix, right? The same situation here, it having 3 different columns, which are namely average of April, last week, and 6 months, right? And different rows here, which are low interest, balance transfer, business, students, airlines, cashback, rewards, bad credit, instant approval, soulcards.com, right? So different n number of columns, n number of rows, but here again the data type is numeric, point to be noted, right? Okay, okay, fine. And see this example, right? So this is again a matrix, right? What kind of matrix is it? Let's start with the recommendation engine. This is the we have studied, and I have I'm using it here in. So this make things very clear, because you have studied in application, and now you're using in metrics in practical form. So things become very easy. That's why I've taken this example, right? So what is the thing? Let's see. Both the things are same, right? So you can say data type is same, correct? Is the data type same? Correct. The data type is same. That is CD. So this is a CD is a item, and so the item is same. So definitely, if the item is same, then the data type is definitely same. So what is this? Recommendation engine works on metrics sometimes. How? So if a person buy this CD, okay, so because these two CDs are similar, okay, right? And so the probability of person to buy this CD becomes very more, right? So this is recommendation engine, and hence this is a type of matrix where the element is this CD, and what is the dimensions? CD has one row, second row, and one column, right? So it can be n number of rows, n number of columns, but at the same time it can have one row also, right? I'm not said it cannot have be one row, it can be one row. So it is having one, sorry, it is having one column and two rows, correct? Okay, and here what the same thing which we have used above. So there user 1 2 3 4, that is four different rows and six different items. So what is the thing, the person who bought uh, item one, so if we talk about user one and user three, we are making similarity between them. How? User one have bought item one, item two, and item three. So we are saying that user three has bought one. So what is likely that user three will also like item two, because it has been bought by user one. So this is making some sort of similarity between them, and the all thing is done going happening is in metrics. Remember this, right? Okay, so this is again one of the user-based filtering part. So again, recommendation system. So basically, it's a depth. We are going depth into machine recommendation system, which is not required at that is at this time. But again, I mean, I love knowing new things. So I feel you guys are also loving to have a lot of new information, right? So challenges what I love to have, and hopefully I feel you are also learning things, so you are challenging yourself. So I feel this thing will definitely interest you, right? So what is this? A user-based filtering. Okay, so there are two kinds of filtering. On one is user-based, second is item-based, right? So what does that mean is filtering can be done on the basis of users here, and here we are doing filtering on the basis of items, correct? So let's study the user-based filtering. So see, if user this buyed grapes, then he buyed strawberry, then he buyed watermelon, and he buyed orange, correct? She has buyed all of these. So now we will see that what are the possibilities that other people will buy. So this is characteristics or data we have of this user. Now if we talk about second user, she has bought only strawberry, nothing else, correct? You can see she has bought only this. Now if we want to do recommendation for this guy, he has bought strawberry as well as watermelon. So can we say that the probability of getting buyed grapes by him is much more, and orange as well, because this customer is showing the feature that she has bought these things, right? So the probability of this customer buying these two things are more likely, correct? And so this is recommending them, these items will get recommended to this person for purchasing, right? And this is based on the user experience we are recommending it. And now this is item based filtering. What is that? So see, this grapes was purchased by this lady and this lady and not this one, only these two ladies, correct? And this what you call strawberry is not purchased by anyone here. But if you see watermelon, see, watermelon is purchased by this guy. See, watermelon is purchased by this guy. Now what is the probability that a person will buy some other thing? See, those who buy watermelon, right, those who buy this watermelon also buy grapes. So there is similarity between these two things, correct? So there is a more probability to be buy grapes, purchase grapes by this man, right? And this is on the basis of item filtering, right? Perfect. Now we have a data frame. So what is data frame? Data frame is nothing but okay. So let me check if anyone have any questions or anything to clear. No.
No questions.
Fine. Everything is fine. Okay. Okay. Perfect. So things are going well, pretty well. Perfect. Okay. Now we are doing data frame. So what is data frame? Data frame again showing the form of matrix. But what differs data frame from matrix and vector is that multiple data types which we were talking about. So see, multiple, it is again have n type of rows, n number of columns, n number of rows, but we can store multiple data types. So we can store numeric, we can store character, we can store logical, and others also, right? We can store anything. So this is the very useful, and we most often use this data frame in our day-to-day life, right, as a data scientist. So basically a collection of lists or snapshots which when assembled together provide a big picture, correct? So it can have n number of rows, n number of columns, and with multiple data types, correct? Okay, so let's move forward. What is the example? See, example, this we have already covered, right? The same as matrix, but with multiple data types. See this example, this is a data frame having a 1, 2, 3, 4, 5, 6, 6 rows, different rows, right? And near about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 different rows and 6 different columns, correct? 14 different rows and 6 different columns. So if we talk about particularly 19th 191 ID, what you can see is it is storing timestamp as well as sampling, as well as samples, then trigger, and what is this? Let me clear this out. Coupling, right? Coupling. Okay. It is storing coupling also. And if you notice that this is a numeric data type, not actually numeric. So this is a character data type. So when you go depth into this, you come to know date is a character data type, because it includes numeric as well as character, and we know when the things include numeric as well as character, it will become character data type, right? So this is a character type, this is a numeric type, then this is also character type, this is also this is numeric type, then character, then character, right? So it is a combination of numeric and character, and hence we can call it as a data frame. In the same manner here, these are the country names and capital, currency name, telephone, and code, right? And there are different 20 rows and 1, 2, 3, 4, 5, 6 columns, right? And they're having very different, if we'll talk about this, very different data types. So this is character, this is again character, this is numeric, and this is again character, right? So multiple data type. Okay, so let's have a look over this. What is this? So data frames are mostly used structure of storing and manipulating data sets. So as I told you, like these are the ones which we use in day-to-day life for manipulation and storing data, mainly because this consists of multiple data types and a data table, data set table, spreadsheet, like these kinds of things. Like the above, DF means data frames have X rows, but terminology is different, right? X rows, but the terminology is different. What is the terminology? That it can store multiple data types. So here the rows are observation and columns are variable, right? So let's say we have a variable HEC, and we can convert anything into data frame by data.frame, right? And let's say this is a variable which stores here eyes, sex, and frequency in it, right? So when we do this thing, so it will convert this variable into data frame, and that's how we'll convert it, okay? And if you want to check what kind of data type this variable now have, then we will use str, that is structure, used for structure, and then variable name that will display that it is a data frame with 32 observations, right? Means 32 different rows and 4 variables, which are here eyes, sex, and frequency, right? So these are different variables which are used in it. Okay. Okay, so now we will get deep into this, like what are the basic operations we can perform. Okay, so operation what we can perform is HEC1 in brackets, right? Or we can also write, so we have discussed this in vectors, but in vectors we had only one row, but here in data frame we have n number of rows, right? N number of rows. So if we talk about n number of rows, then the things become like we'll write heck, this variable which we have done, heck, square brackets. If we say 6, or it is a big number, if we say 1 comma 2, then what does this mean? First you have to understand this. So this means is we are denoting 1 as a row and 2 as a column. So simple rule is row and column, right? So this is denoting row and this is column. If you're fine with this, then let's start with what is written here, right? So what is showing here is, so see, we can write the same situation in very different ways. We can write it as heck, square brackets and 1. We can also write in this way. We can write in this way also, right? It does the same work for us. And what is that? It will store the first column, only the column, right? So here it will store first column, displays the first column, and what is doing here? So our first column name is here, as we know. So it is doing first column here column of heck, right? So same, one of the same thing. Or we can also do with the dollar sign. It is again means the here column of heck variable or heck data frame, right? Same thing you can write and the output will be same. So we are assigning this value to heck1, and we'll do heck1 and press enter, sorry, run. Then we come to know that it will store all the values of here, right, which is showing here. These are the different values. Okay, so when we do str, that means structure. It wants us to display the structure, and that is here factor. So now we will discuss what is factor. Okay, what is factor, and we will discuss it in further slides. But let's for now make it that str means structure. Okay, and now this and this will return the column D frame, because these are both the same thing as we have discussed above, right? So when we do this and assign value to heck2, and when do heck2, it with str2, right? So it will display that in heck2 we are having 32 observations, but one variable that is here only, right? And those are factors with the variable names and 1, 2, 3, 4. Okay, and again the same thing which we are doing here also we are storing in heck4. So the same thing we are storing in heck1, heck2 and heck4, same thing, very same thing. Okay, so when we compare heck2 and heck4, the result comes out to be very true, because we have stored the same things, so the result will be same, right? There will be no different, correct? Okay, now the thing is returning multiple column in a data frame. So this is the same as heck C1 form. That means now we were storing only one column, and here we will store multiple columns of that data frame. So 1, 4 means first column as well as fourth column of the same data frame. So this can be written as this also, right? We know first column name is here, fourth is frequency, and we are assigning it to heck5. And when we see structure of heck5, that will show 32 objects with 2 variables, which is here and frequency. And we can see all the variables of here and frequency here, right? Very simple. Perfect. Okay. And some more few operations over the same data frame is heck return as row. So we have discussed, like if we write heck 1, 5, right? So 1 means row and 5 means column. So you see 1 comma and there's no value. That means it wants to take only first row, and all the columns should be included, right? All the columns. If it's written nothing, that means all. This is pre-assumption, right? So when we write this, then it will get displayed. First row, it is first row and all the columns here, I, sex, frequency, all the columns. Okay, so how to do subsetting and made easier? Subsetting means taking a part from a data frame and assigning it to some other data frame or variable, right? How is it possible? See, so we use subset function. We will use variable name, which is heck, and selecting only the here column, right? And when we do structure str of this, then we'll get 32 observation and only one variable, which is here, and this will get stored in our hex 6, right? This is the same thing which we have done, but in a very different ways we can do the things, right? Okay, now again we are storing hex 7, we are storing into hex 7, we are doing subsetting, hex variable we have taken, and we are selecting now multiple columns here as well as that. And when we do structuring of it, we'll see 32 observation with 2 variables. And what are those variables? Hairs and eyes, right? So these these values will get stored in hex 7. How about hex 8? Again, subsetting the variable name which you want to store, taking from this variable, right? Subsetting here equal to black and I equal to brown. So here comes the things, right? We are using all the things which we have learned till now in this example. And how is it? It's like, see, we are taking values from hex, right? Subsetting in this, and how here is equal to black. Here is equal to black means wherever you find here equal to black, take that value, and wherever the I is equal to brown, take that value. And both conditions should be true. Wherever any one condition is getting false, then do not please take that. If both are true, only then take that. And how do we know? By using AND operator, right? So AND operator says if both the condition like C1 and C2, if both are true, only then situation becomes true. And if anyone is false, then situation becomes false. And if we take OR, so that is a bit different, C1 and C2, let's say. So if C1 is true and C2 is false, then it will again take it as true. Because what OR statement says, OR says that any one of the condition if true, then the resultant would be true. Fine. So here you got, I feel, wherever here is equal to black and I is equal to brown, if both the condition gets true, store those values. Fine, let's see. So hex 8 gets stored here. See, here column has black both, eyes have brown both, and male is, sex is male and female, and frequency and so on, right? So these are taking only, here is taking as black and eyes are taking as brown. Only those values are here. Others are not. Others are absent. Okay, right. So now how to combine two data frames? So again, this is a very good thing. cbind is combining. How to combine it? Okay, so we have hex 2 we have defined earlier, and we have hex 4 again decided in last slide, right? So we can do cbind comma hex 1 hex 2 comma hex 4, and it will just give us a combination. So this is very helpful because there are a lot of functions pre-made, that is called predefined functions in C, in R, which is helpful in, you know, getting out things sorted in very easy manner, right? So when we say echo, which is a variable here, okay, so it will display the columns of hex 2 and hex 4 here, right? You can see here and here because both the data frames have the same value, and that's why it is showing here with the same elements and here with the same elements, right? If you remember, so we have stored the same values in hex 2 as well as hex 4, right? That's why. And what is stack in two data frames? That this is a union. And what is union means? So union means, see from this example, rbind. So rbind is used to get union, whereas cbind is used to get combining, and rbind is used to get union, right? And how it is getting, hex 8 is a variable and we are union, and we are making union of hex 8 with hex 8. And union means something I'll display, I'll tell you. See, this is something, a universe. Universe is like a population. I mean, all possible outcomes. If this is a universe, forget this, this is a universe, and this is set A, and this is set B, and if I say A union B, so this is universe. So please do not get confused between this sign and this. So this is universe. I have written UNI, and this is a sign of union, right? U, union, okay? And when we write this, then what does that mean? This means how much area is collected under this part. This means this as well as this. So everything included in A as well as B comes under A union B. So here, if we check Hec A contain this part. This is the overall population of Hec A. And again, the same thing. Give me a moment. Okay. So Hec A contain this part, right? Because this is a stacking of two. Union comes stacking, right? So these are the elements of Hec A, Hec 8, right? And this is again repeating it because we are combining two Hec 8, right? So this is first part, you can say A, and this is B, right? And this is our universe. This is we have studied in sets, right? This is our universe. This is A element, this is B. So everything is included, right? Hope that this helps you. Okay, fine. Okay, so this is something which is very, very important in data frame. Okay, now let's come to list. Now what is list? List is again very, very useful. Like data frame, list is again very useful. So but how it differs from data frame, we'll check it on. That list contains only one row and n number of columns. So it, but multiple data types. So see this, like this. Only one row it has, but different columns it has, right? And the major part is it has multiple data types. You can add numeric, right? You can add character, you can add logical and whatnot, everything, right? Everything, okay? So what are the uses? The detailed information for a person. So if you want detailed information, let's see here, see this example. This is a very, very good example. And what is it? Like Cascades Apartments. This is apartments in Sunnyvale, CA, right? In CA. So what it includes is this monthly charges, rent. This is numeric as well as dollar. So it becomes character type. Like studio is 2 bed. It again become character type. Then 1-2 bath, 455 square feet. This is numeric type, right? So these are the different data types which we have used in list, but it should have only okay, it should have only one row, as we have discussed, just the one row with n number of columns, whatever you want, and data type can be anything which you need. Okay, so just check it out. What are the other examples? Okay, see example here. Yeah, so see, this is a list, and see, this is a list. You can assume it, we always make it like this way, horizontal, but here you can assume it in vertical way, right? So this is one data type. Second, this is character, numeric, character, numeric, 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 character, right? So everything this, if we make it in horizontal way, so it will become list, right? It will become list. And these are the different things of this example, and which is I'll tell you. See, first is forecast. So in forecast, we see mostly it's sunny, right? This is the other different things, and different things which are used at different times. So right, so it includes numeric, date as well, and character type as well. So these are the different things which we have written here. Okay, so you can go through, very, very simple. Okay, again, so you must have seen products in Amazon, especially for books. So you can see series, it's a character type, it's a numeric type. If we include pages also, then it will become character type, right? And this is again a date and a character type. Then here it becomes character type, numeric and character, so become character type. This is character type, right? So different kind of items, elements in a list. So if we combine all this and make a list, then that will be very, very fine, right? So this is one of the example, and the other example is Philippines. So this is the country, right? So my voice is getting throat is getting short. Okay, anyways, so this is the country, and again, so different what you call elements, like character type, numeric type, and I mean different multiple data types which we can use in lists. So this is again one of the very good example which you can understand, and hope this is helping. And in case if you have any doubt, please do let me know, then we can clear it here only, right? Okay, so some basic operations in list. So let me tell you one thing, like, you know, as you have gone through vectors, lists, and sorry, metrics and data frame, so now it will not be difficult to you to catch all these things. Why? Because you have covered those things. So the basic operation you already know how to combine and all those things, right? So let's see here. Here it's 1 into n rows, which means 1 row and n columns and multiple data types. This is what list is called. So we are combining this and storing it C, A, B, C, storing in C1, and this is numeric type we are storing in N1. Okay, so we are making a list. We can make list by this function. Okay, and we are combining C1 here, N1 here, which is numeric type. Then system.date is, it will print date, and true means it will display true everywhere, right, wherever it is required. And when we do L2 and run, so it will display like this: ABC 1, 2, 3, date, and true, correct? And when we want to see structure, we can see their list of fours. We have 4 different columns, which is this one, this one, this one, and this one. Okay, fine. And now if we do L2 braces 4, that means we are calling this one, this particular 4th column, or you can say this one, this particular column, right? So it will display true. And when we say L2 1, that means it is calling very first column, that is A, B, and C. Okay. And how do we append in a list? Okay, so list, append to list, the result get trippy. Okay, so how it works? So it work is like, we make first list and we include L2. We have already made L2 here, you remember, right? We have made this and we have done some exploration over the same. And pi is some special keyword, and whenever we do L2 with print sign, so you can say very first column contains so here pi will get just included in that in the as a very next column, right? Nothing will make difference because it is appending, right? Appending in column, because it can have only one row and multiple columns, so that's why it is appending in column, right? So see, this is first column which we have discussed, numeric, date, true, and the pi getting appended here only, correct? Okay, great, great. Okay, so let's move forward. Okay, what are factors? So see, factors, again we have we need to done this. So factors stores each distinct value only only once, and all data itself is stored as a vector for integers, right? So what basically factor does is, factors make things in factor form, or you can say in a level form, right? So let's take an example, and that will make a more clear view. So let's say a week is a variable, and we are concatenating Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, right? And so this is we are concatenating and we have made this variable, and now we are factoring. And how to do factor? Using this keyword function factor, and then the variable name. Now WF will contain the factors, right? Factors. Okay, so factors are also called levels to understand, and let me give you an example that will make you much clear that what exactly factor is. See, so let's say WF is a column, right, which contains a factor of Tuesday, and we will assume it Tuesday as T. Uh, 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 let's start with Monday. Okay, so Monday as M, Tuesday as T, Wednesday as W, then Thursday as TH, and Friday as F, right? So these are the only elements which are present in this particular column. Maybe the number of elements can differ. There can be multiple number of M's, right? Can be only one T Tuesday, can be multiple number of Fs and only one W, any condition, right? But these values are present in our column WF. This is what called factor, right? So whenever we want to know like what all elements without any repetition, or you can say the unique elements in particular data, in particular column, right? So we use factors, right? This is the main function, and hence when you give hands-on over this, you'll come to know lot different uses and very useful factor. Okay, great. Now you have come to user-defined function. So user-defined function is nothing but a function which is defined by user. Let's say this is a factor, this is a predefined function, right? And you can also define your own function as per your project, right? If you want to define some function, and how you can define, this is a syntax function, a, right, any variable, and then your operation what you want to do in square bracket, sorry, curly braces, right, curly braces. Okay, and this value is here is getting stored in F, and hence when we pass F2, this is called calling of a function F2, right? So this is called calling of a function. When we'll pass F is equal to 2, so what it will do is 2 value will go to this, and this F contains this function, so 2 will go to here, okay, 2 will go here as A will replace by 2, and A will get into this, and so the to the power of 2, so this sign shows power, right? So to the power of 2 is 4, and the result is 4, right? So nothing but you will give an input, and right, and function will process whatever it operation you have given, like here we have given this, and will give you output, as simple as that, right? So okay, so let's take these few example statements, right? So function can be passed as an argument to other function, correct? Function behavior is defined inside the curly braces we have done here. Function can be nested, or so that you can define a function inside another function, right? So this is something function here, and you can define some other function also, right? As per your needs, you can use these coding skills, right? So you can do anything and everything, whatever you require. So this is nested kind of thing. The return value of a function is the last expression evaluated, right? So the last value which is encountered, right? So that is called the last expression, and that will be the result. Fine, that is very clear. Okay. Uh, right. This is okay. So we are just two slides away from our target, correct? And here comes the packages. So what are packages? And packages are, you know, this is a God gift, I would say, right? So packages, you know, lot of people in our community are making packages for us to use, right? So it's a bunch of code which you can use for your coding, right? So I'll explain you. See, like this search, if you enter this command in your RStudio, what it will do is search for installed package and dataset, and I'll tell you really this is a very useful thing because most of the time even I used to search that, because there are a lot of packages which you keep on installing in different projects, and there is no such facility in R language to know that what all packages are installed in your RStudio, and hence I have come with this thing uh, that you can check just what all packages are installed in your RStudio. You'll just type this one and you'll come with results like here. When I have done this, I am with dot global environment, MTR cars, tools, RStudio, and all others things, whatnot, right? So this is to just search it on. And then library ggplot2. So remember while I was telling you about graphs, right? So there we have seen, I have told you about ggplot. So ggplot2 is the next version of ggplot, right? So library ggplot will do nothing but load your package. So before doing anything, you know, in RStudio, we need to first install our package and installation, and after installation we need to load our package, right? And how to load and install we will cover in very detail in our course. So please join our course and let us know in detail. Okay, and once you are done with this, so this is basically for loading, so you can done through this, or if you want to do it with the buttons, then you can also do with the RStudio. There you have a buttons and you can do it, and after you are done it shows attaching package ggplotto, right? So this shows that your package has installed. Okay, data, list of all available data sets. What all data sets are available to you in your GUI, that will be shown by this command. Very useful. I mean, I love these kinds of commands by which you come to know that should I install this package or not, should I install this data or not, because sometimes the things are already installed in your system, and just because you have done this few days or few weeks before, so you do not remember, so you can check this using these commands. Very useful, I would say. Okay, so now come to the special values. Yeah, so we are keep using the pi value, right? So this is, as I've told you, is a special value. You can use only small pi, this will work, otherwise this and this will not work. And remember my words that R is a case sensitive language, right? So the case sensitive language, right? So it depends what cases you are using. So if you have stored a variable called v1, and if you will put into capital V1 or only capital V, it will not give you result unless you use small v1, because it's a very case sensitive. Hope you are clear with case sensitive thing, right? Okay, if you use NIF, that stands for infinity. Again, 1 upon 0 is called infinity, which is uh, this one. Okay, so NA means not available. A logical of a constant, sorry, a logical constant of length 1, that means neither true nor false, right? And right, so and tell function to ignore NAs. If you know, if you want to so this is a function as we have discussed, and you can pass any argument. Okay, so if you want in your data set, because in a lot of the data sets there are NAs mentioned which is not available thing, right? So if you want to do not consider that thing, then you can use this command na.rm is equal to true, which means you should remove. RM means remove na, and this condition should be true. So keep removing na wherever you find. So these are some bit advanced level, or we can say while using doing manipulation data analysis, you use these kinds of things. So I'm just making you aware of these things, so that it will be, you become just you come under connection with these kinds of thing. And then again, when you are doing data analysis, then you come to know about this again, and then you feel it's more familiar to you, and that will be easy to accept these terms, right? So these are some tricks, right? Okay, and hope you appreciate this. Thank you so much. Okay, and check for NA values is dot NA, and then variable name. So what this does is dot NA, right? So it's as simple as in English we say na, is NA. It's again the same thing, not available. Is NA there, right? This is simple English, right? Or we can replace NA with anything. Is cat there, or is my phone there? In the same sense, is dot NA means is NA there? If it is there, then it will display true. If it's not, then it will false, right? Simple, very simple. Okay, what is null? It's an empty value not allowed in vectors, matrices, vectors or matrices, only allowed in data frames and list. Again, is dot null means is null available. So in data sets, if null available, then it will display true, otherwise false. And what is NaN? It's not a number. Remember, Na is not available. NaN is not a number. So numeric data type value for undefined, like 0 by 0, right? And if you see, this is not the thing which you should give lot of time. But yeah, I have seen a lot of people get confused in NaN, Na is null. And again, these are part of data set. So as I have told you, the more you understand your data, the relationship with your data becomes very, very friendly, right? In the same sense, the more understand you the things which are using in data, so NA, null, NA, and these are the things which are going to use in data set. And the more you get familiar with this, do not ignore anything, because if you ignore something, then that is the only thing which will pain you in long run. So keep making things very, very clear. Ask me, or there are a lot of different forums. I'll tell you by the end of this slide, right? So you can get familiar with all those things, correct? And those makes your life very, very easier. True. Okay. So this you can click over this, right? So I have thrown a link here by which you can go through. There is a article over NA and null difference. So you can go through that if you want to get into deep over this, right? Very, very helpful. Okay. Okay. So last we are coming with functions. So till now, whatever we have studied, and even here we'll study some of them, those are predefined functions. Predefined functions means the functions which you have used, sorry, which are defined earlier by other people, and user defined functions are the ones which you will define. And how to define those functions, I have already uh, told you the syntax. Here it is, right? So this is the way you can define the function. Fine. And okay, so these are the type conversions, right? So what are type conversions means? If you want to convert one data type into another data type, very, very helpful, I'll tell you, very helpful. These are the small basic things which, you know, when we learn big things and we forget about small things, and always remember the small things are the ones which always should be concentrated, and that will help in long run. So doing small things can make a big change, right? This is the thought you should always remember in doing in any of the work, right? Okay, and so as dot character X, what it does is it will convert into character type, whatever type. Earlier it would be maybe numeric, complex, or logical. It will convert into character type. It will convert it to complex, which is not very useful. But again, not used by us. But again, I mean, you should have a knowledge of this. And then numeric, very, very useful. You have to convert many characters. Again, this is character type is very useful. You want to convert any type to numeric type. Let's say like this is written, right? Why would you convert A into numeric type, right? So you'll convert this kind of situation, like let's say this is written, right? So this is a numeric type, but as it's written code, so it becomes a character type. So you want to convert this into a numeric type, then you can convert it using this statement, right? And if you want to convert anything into logical, then you can use this statement as dot logical. Simple, right? Okay, so structured conversions. Structure conversion means that if you want to convert data structures, one data structure into another, you can use this. How is it? If you want to convert any type into data frame, you can use as.data.frame and the variable name. As.list.variable tells you the conversion of list, any form to list, any form to matrix, we'll use as.matrix, any form to vector, we'll use as.vector thing, right? Very simple. Okay, date processing. Okay, so again, a few basic thing the people ask is, okay, we can write date, but how to write it? Okay, so the simple way is this statement, sys, remember capital S, then small, dot capital D, then small, and braces, right? So it will give you the current date. As dot date, what it will do, like these things we're doing, conversion. So it will convert anything into, you know, into date, like this format. So it will convert this into date, and it will store into two variable. And when you do mode 2, so it will show numeric, and when you do class 2, then it will give you date, right? So this is a class, but the mode, that is data type, is again numeric, right? Okay, and last thing is sequencing. So sequencing means making a sequence of things, right? So we use SEQ, and then braces, then first thing, comma, second thing, comma, third thing. What is that? So this is your sequence starts from 1, right? Goes till 10, and what should be the difference in between them? That should be 2, right? Simple. Starts from 1, goes till 10, and what should be the difference in between them? It should be 2. See, starts from 1, goes till 10. See, I'll tell you why it is not displaying 10, and difference should be 2. How? 1, 2, 3, right? 3 is 2 difference, then 2 difference, then 2 difference, then 2 difference. Okay, now what is the thing? It is not including the outer part 10, and even though if you think like after 9, the after 9 and the difference of 2, the number will come 11. So how can the 11 be displayed if the limit is only 10, right? So this is the thing, it's written 9 here. Don't be confused. Okay, and repeat, what it does is this is the syntax, rep x comma n times. So what you want to repeat, the thing here which you want to repeat, variable, or again you can put the thing exactly, I'll show here, and number of times you repeat, you can put it here. Okay, how the thing work is like 1 to 3 means 1, 1, 2 and 3. That's how it works, and you want to repeat it twice, so 1, 2, 3 and 1, 2, 3. Perfect, fine. Okay, okay, great. So we come to an end of this session, and hope everyone liked it. Okay, so okay, so before closing this, as I have promised you that I'll share some useful resources with you. Uh, um, okay, so I'll definitely fall. See, our language useful resources means, you can get you can learn. If you get stuck anywhere, you can get help from that, right? So community, and there are a lot of blogs, but some of them are very useful, very known, and so there are a lot of details in the internet, on the internet, but the things which are useful for me, I'm sharing with you. So no personal things, right? uh, Okay, so our bloggers is as a site which is a father of our language. You can find each and everything, any article, anything over this for any help, for any learning purpose, right? And then Stack Overflow is something which if you get stuck anywhere, you can get help from this, right? Uh, you can help from this. You can get help from this. Uh, and then third we have Kaggle. So this is somewhere where you can compete with others once you have a good understanding and hands-on over R or any other language. Right, so hands-on is very much required, and Kaggle is a competition platform where you can compete with other people's, right? So it can be used in late times of your day, but again very useful and important. And the fourth one is R Weekly. So this is again a blog which I use mostly to get help. So there are a lot of different people who are helping, and blogs, you can read it from here, right? And then we have Reddit. What is called R Blogger. Very helpful, guys, believe me. R blogging, very helpful, and you can use this also. And there are lots of cheat sheets present over the internet. Okay, so cheat sheets for different packages, oh, for different packages in R. So I would say just take it them as a as a reference point, learn from them few things, and once whenever you stuck, use that. So that is very useful, or you can paste it wherever you work, right? So once you are stuck, you can just put your head up and you can see that these things are present, and that will be really very time saving and very helpful things, right? Which I mostly use. And last but not the least, very important thing, that the community is growing um, at very fast pace. So never uh, get discouraged, right? Just keep moving and hit the bullseye. Right, so this is the only thing. Never get discouraged. There are times when you'll feel like, oh, when I'm stuck, I'm like dull or something, right? So this things happens in everyone in every life, right? So but if you have to keep moving, you I mean, do not stop anywhere. Maybe you cannot walk, just crawl. Right, but keep moving, keep learning something, right? Just give 4 to 5 hours in a week at least to learn something, and definitely you will be perfect and master the things in many different ways. Believe me, that is very practical thing which I have done in my own, right? And this is all I can share. So hopefully you can get this. I'll just make it view. Okay, so you can follow this, and in case you find uh, the thing is, if you find this demo class helpful, then please let us know by sharing it with more people, and letting everyone know about the same, right? And helping others, right? And let us know in the comments also if you find anything interesting particularly, or anything you want to motivate anyone. So help and help, right? Help everywhere. Okay, fine, great. So it was great taking this session, and lovely for giving your time, right? And thank you so much. I'll be very thankful to all. Yeah, thank you.